We're going to talk about ionic reactions and how to use the solubility rules to predict the products of a precipitation reaction. A precipitate is an insoluble product that forms from the reaction of soluble reactants. We can identify a precipitate in a chemical equation because its phase would be a solid. It would have a little S next to it. We can use the solubility rules to predict these products. Remember that the solubility rules are only used for the products. The reactants should be soluble, meaning AQ. So if your products are soluble, they get the symbol AQ, which means aqueous. And you read the table by looking at the exceptions to the rules. For example, group 1 metal cations and the ammonium ion products are all soluble. The halide ions, which is group 7, are all soluble except when the halide is bonded to one of these cations. If the product has one of these cations, then it gets the insoluble symbol, and the insoluble symbol means S. The acetates, the bicarbonates, the nitrates, and the chlorates are all soluble. The sulfite ion is soluble except when it is bonded to one of these cations. This makes it insoluble. Insoluble products get the symbol S. So carbonates, chromates, phosphates, and sulfide ions are all insoluble, S, except when they are bonded to these exceptions. So they become soluble, and the soluble symbol is AQ. Hydroxides are mostly insoluble, except when they are bonded to these exceptions. Let's take a look at an example. Write a balanced chemical equation when aqueous solution of potassium iodide is mixed with aqueous solution of lead 2 nitrate. So let's start off with our reactants. Aqueous potassium iodide plus aqueous lead 2 nitrate. And we want to predict the products with its correct phases. So on scrap paper, you want to break up your reactants into cations and anions. Potassium iodide is made up of K plus, I minus. Lead 2 nitrate is made up of lead 2 and NO3 minus. I want to predict products, so I'm going to bond a cation with an anion. Remember that the cation is always written first. So my K is my positive, so I'm going to bond K plus with NO3 minus. I'm going to crisscross the charges, and I'm going to write down what that makes. I got to use my solubility rules to figure out what the symbol is for KNO3, the phase. Now it says that nitrates are soluble. Nitrates are soluble. So that means it gets the AQ symbol. I got to do another grouping. I'm going to group the lead 2 with the I minus. Remember that the cation comes first. I'm going to crisscross the charges, and I'm going to get PBI2. I have to use the table to figure out what would be the symbol for lead 2 iodide. So I'm going to take a look at the table, and I see that halides are mostly soluble except when it's bonded to lead 2. That becomes insoluble. The insoluble symbol is my S. We're not quite done. We have to make sure this reaction is balanced. So we're going to put a 2 and we're going to put a 2 in front of potassium nitrate. So this is going to be our final answer. And to get full credit, you have to show the correct balance and the correct phases. Let's do another example. Write a balanced chemical equation when aqueous solution of magnesium sulfate is mixed with aqueous solution of barium nitrate. So, magnesium sulfate, aqueous, plus and now we have to predict the product. So the first thing you want to do on scrap paper is to go ahead and break up your reactants to cations and anions. Magnesium is 2 plus, sulfate is 2 minus, barium is 2 plus, and nitrate is minus. So I'm going to go ahead and pair up my cations with a new anion. So magnesium is going to bond with nitrate. I'm going to crisscross its charges and make up a new molecule. I want to see what type of phase this gets. So I'm going to look up my nitrates, and nitrates are right here, and nitrates are soluble. So soluble means it gets the AQ symbol. And I'm going to bond barium with sulfate, and I'm going to get BaSO4. I'm going to look at my table, and it says that sulfate is mostly soluble except with barium. It becomes insoluble. So insoluble means it gets the S symbol. And before I call this my final answer, I have to make sure that this is balanced, and this is a balanced chemical equation. Let's talk about equations for ionic reactions. We have 3 different types of equations that we can identify the spectator ions from. The molecular equation is a balanced chemical equation in which all of your reactants and products are represented as neutral substances and the phases are shown. So you should have no charges, but you should always show your phases. Your complete ionic equation is a chemical equation in which all dissolved ionic reactants and products are represented by dissociated ions, meaning cations and anions, and you still show phases. The net ionic equation is a chemical equation that shows only the ions in compounds that are directly involved in the chemical reaction. You still show phases for that. And your spectator ions are ions in which do not participate in chemical reactions and are present at the same on both sides of the reaction. Let's take a look at an example. Write down the molecular equation, the complete ionic equation, and the net ionic equation, and identify the spectator ions when aqueous solutions of phosphoric acid and calcium chloride are mixed. When you are doing these types of reactions, you have to label your reactions. So we're going to always start off with the molecular equation. Molecular equation is just a balanced equation that shows your phases. So we are talking about phosphoric acid, aqueous, plus calcium chloride, aqueous. Remember, we're going to separate our reactants into cations and anions. So this would be and calcium chloride is calcium. And you can do this on scrap work. You want to go ahead and H plus with Cl minus is going to give you HCl. You're going to use the table. Halides are mostly soluble, except with these exceptions. H is not one of the exceptions, so it gets the symbol AQ. Plus, then I'm going to go ahead and bond this cation with this anion. And I'm going to take a look at my table. Phosphates are insoluble, and calcium is not one of the exceptions, so it gets the S symbol. Now, this is not a complete molecular equation because it's not balanced. So go ahead and balance that. Now we have our scrapwork. It's going to help us a lot. It's going to make the process go a little faster because we've already done most of the work. So molecular equation is first. The second thing we want to do is write down the complete ionic equation. And the complete ionic equation says that you break up anything that's aqueous into its proper cations and anions, but you have to keep the balance through and the phases. So phosphoric acid is aqueous, and on our scrapwork we said that the cation is H plus and our anion is PO43 minus. We're going to use that to help us. Now we need to make sure we get the balance correct. There are 6 units of H plus. 2 times 3 is 6. We still have to say aqueous. And there are 2 units of the phosphate ion. Calcium chloride is made up of Ca2 plus and Cl minus. So there's 3 units of the cation and 6 units. So 3 times 2 is 6 Cl minus. Don't forget the phases. For the products, we have 6H plus 6 Cl minus. Now take a look at the calcium phosphate. The calcium phosphate is insoluble. We don't break that up. We only break the aqueous. So we just write down the whole entire product as a whole. Then I write down my net ionic. Net ionic means I'm going to clean up my complete ionic. Whatever appears on both sides, we have to cancel out. So there is a 6H plus on the left, and there's a 6H plus on the right. And there's a 6Cl minus on the left, and there's a 6Cl minus on the right. So I'm going to write down what's left over. I like to always start off with my cations. Don't forget the phase. Okay, and it's also asking us to identify the spectator ions. The spectator ions are the ions that got canceled out. What got canceled out? My H plus and my Cl minus. Let's do another example. Write the molecular equation, complete ionic equation, net ionic equation, and identify the spectator ions when aqueous solutions of aluminum chloride and sodium hydroxide are mixed. I have to label my equations. So it says aluminum chloride, aqueous, plus sodium hydroxide, aqueous. I want to break up my reactants into cations and anions. and I want to regroup these. So aluminum is going to bond to the hydroxide, and we're going to get aluminum hydroxide. I think we can't see that very well. I'm going to take a look at the table. Hydroxides are usually insoluble. Aluminum is not the exception, so it gets the symbol S. And then I'm going to group sodium with chlorine. So I would get, we're going to take a look at our table. Halides are usually soluble. Sodium is not one of the exception, so it gets the aqueous symbol. This is not a complete molecular equation because this reaction is not balanced, so we're going to have to balance this. Okay, now we have a complete molecular equation. We should have our scrap work to the side to help us out with the complete ionic equation. Remember that the complete ionic equation means that you completely break up all the aqueous, keeping the phases and the balancing throughout. Aluminum chloride. It is made up of aluminum, 3 plus aqueous, and there are 3 units of the chloride ion. Sodium hydroxide. There are 3 sodium cations and 3 hydroxides. Aluminum hydroxide is a solid. We don't break that up. We just write it down. Don't forget the phase. And sodium chloride is aqueous. I break that up, keeping the balance and the phases all there. After complete ionic comes the net ionic. And we're just going to clean up our complete ionic. Whatever appears on both sides get canceled out. So there's 3 Cl minus, 3 Cl minus, 3 sodiums, 3 sodiums. So I just write down what's left over. And now we're able to identify our spectator ions. The spectator ions are the ones that get canceled out. So sodium plus, Cl minus. Good luck and keep practicing.